Okay, so in this section, we're quickly going to talk about the sprite node. So in this scene, I've gone ahead and brought in a tree from SpeedTree right quick, and I've loaded up the diffuse image as well as the opacity image, piped them into their corresponding ports, and piped it out to the surface, as is a typical leaf shading pipeline. And what we're going to end up with is a scene where Redshift is having to trace many layers of transparency depth in order to resolve all of these opacity cutouts. Here's where the sprite node comes in. In order to make this a more efficient computation, they've implemented the sprite node, in which you simply load your opacity texture into the sprite node and pipe your material node into the sprite node. And then from the sprite node, we pipe out to the surface. And if you have a lot of pixels where you're tracing through multiple layers of opacity, this actually can speed up your render quite a bit. I've gone ahead and done a comparison here where with the sprite node, it took me 16 seconds to render this image, and with the traditional cutout opacity approach, it took me 28 seconds to render. Now, I'd like to note that there is a little bit of a shading difference between these two approaches. On the top here, we have the sprite node. On the bottom, we have the traditional opacity route. And if you notice in some of these dark sections, it seems like we get a little bit more of a dark shading to our result. So that is just something to keep in mind when using the sprite node. Anyway, there are more applications that you might use this for than simply a tree with leaves, but pretty much anytime you have overlapping transparency, you'll definitely see some gains from using the more optimized approach of the sprite node for your opacity cutouts. Anyway, thank you for checking out the sprite node section, and we'll see you in the next one.